I'm with Franck Lahaye, the founder of Airthium, a breakthrough heat engine that aims to replace fossil fuels. Their heat engines allow the industry and the electrical grid to stop polluting at scale in a cost-effective way. So if I understand correctly, your heat engine is for the industrial purpose as opposed to the purpose for usage in homes. Can you describe the difference for us?
Correct. The difference is the size of the machine. The heat pumps you'll have in your home are very small. An industrial heat pump will be in the megawatt scale, so thousands of little machines combined into one. So
factories, which is what your heat engines are going to be powering, produce physical goods, and that requires lots of heat and electricity, which usually comes from fossil fuels like coal, natural gas, oil, that's super polluting. And your engine aims to replace this dirty source of energy with clean energy. So can you talk about what is the heat source of your engine, of your heat engine?
Correct. So just to put things into perspective, industrial heat today is everything that goes from heating the building with AC of the factory up to thousands of Fahrenheit to melt glass, to make steel, to make cement. All of that represents 22% of the world's CO2 emission. It's absolutely massive.
What's the rest?
The rest
of the emissions? Is it the number one polluter?
No. You have production of electricity, you have transportation, you have lots of sources that can emit CO2. But making goods require heat, and this heat is a lot of what represents the CO2 emissions in the world today. So the most polluting processes are the one that works at very high temperature. And the one we're looking at, decarbonising, are the one between 300 Fahrenheit and 1000 Fahrenheit. And this is about 3% of the world's CO2 emission. So much lower, but still a good chunk. And what we're doing today is trying to address a market that we cannot decarbonize until now, which is the production of heat above 360 Fahrenheit. So for some reasons, technical reasons mainly, the heat pumps that we have today are limited in temperature. They have seals and joints and things that prevent them going high in temperature. So above 360, the only solution is to burn fossil fuels, mostly natural gas. So you can make steam in a natural gas-fired boilers, you can make hot air to dry goods, you have lots of applications. And this is what we're targeting with this heat pump. It's the only one that'll be able to reach 1000 Fahrenheit.
So your website says that you convert heat to electricity, but also electricity to heat. Correct. Can you describe both use cases and when would you use each?
Yes. So what we're making is actually called a Stirling engine. It's a machine that converts electricity to heat and heat to electricity. So in one way it works as a generation from heat to electricity, and the other side is a heat pump. And so you asked in the previous question, what's the energy source of this heat pump? It's electricity.
But electricity, where does the electricity come from?
So the electricity, that's a part of the question is, this electricity today in America mostly comes from natural gas. And so the problem we have now is the same as when you buy an electric car. Great, you don't pollute anymore with your car, but you just move the pollution from your car where the fuel was burned to the place where the electricity is produced. So in this case, the natural gas-fired power plant. And so the next step will be to decarbonize the production of electricity. And we have a solution for that. We can talk about it after. But yes, that's the plan, is to electrify where we can and then figure out how to make sure the electricity that powers those systems is green.
Well, that's exactly what I wanted to talk about. Like how is your engine powered to make it sustainable and make it clean?
So let's say you're a factory today, paper factory. You need to dry your paper at 800, 900 Fahrenheit. Instead of burning natural gas, you contact us and you install a heat pump. Now, instead of sourcing natural gas, you need to buy electricity. The easy choice is to buy it from the grid. So if you live in a place where there are lots of renewable in your grid, let's say Costa Rica, great, your process will be clean. If you live in the United States, then your best option is to buy what we call a power purchase agreement with a solar farm, and you buy their production. Now, the solar farms, we all know that they only produce electricity during the day. When there are clouds or at night, it doesn't produce. So you will still have to buy electricity from the grid at night. And it's still electricity that comes from natural gas. So once you've done that, the next step is to add storage. So there are a lot of companies right now that provide what we call thermal storage. It's a big container with bricks or molten salt or sand that can keep the temperature up to 1,000 Fahrenheit for, let's say, 10, 20, 30 hours. So if you install this at your factory and you buy a lot of solar capacity during the day, you use that capacity, that electricity to produce heat. You use some of that heat for your process, and the extra electricity, the extra heat, you store it. And you can reuse it at night when needed. With a combination of power purchase agreement, a solar farm, or from a wind farm, and storage, you can get 80 to 90% of your need from a renewable source.
Some argue that even the production of solar farms and solar panels is dirty, right? And that actually the production, the emissions that result from the production and the transportation of the solar panels and creation of the solar farms are higher than the actual utility of, the energy that gets produced from the solar panel. Would you agree, disagree with that? Do you have any statistics on it?
I don't
Because solar cells are only like 20% efficient, right? And then the panels have to be replaced. So that, again, emits more CO2 into the atmosphere.
Correct. So the production of the panels, what emits CO2 is the mining to get the materials to make the panels.
Yeah.
The mining today, those trucks that do the mining are powered by fossil fuels. Tomorrow, maybe they'll be electric. And yes, mining pollutes because you extract those materials from the soil and it can pollute the environment around it. But we have to pick our battle. Do we want to pollute the whole planet with CO2 emissions and NOx emission, or just have a place in the desert where you just dump those panels and store them until we find a way to recycle them? But the whole process of transporting the panel, producing them, emits way less CO2 than what they can produce of green electricity over their lifetime. So I think that's not an issue. The main issue we're facing today is the intermittency of renewable. So those last 10% I mentioned, when you want to decarbonize completely the grid and retire fully the coal and gas-fired power plant, is the hard part. You need to find a source that can store that energy, like a system that can store the energy for thousands of hours. So whatever happens, bad weather for 2 weeks, you can guarantee that you'll have green electricity available to finally retire those power plants. This is another product that will work in a few years using the same engine. We plan to add 2 storage systems, a thermal storage to do day-to-day, and an ammonia storage. So it's a very dense fuel that you can produce from green hydrogen to have a seasonal energy storage system. So that's really why we started Airthium, is to build this storage system. And the heat pump for us is just a way to go to market faster by only selling the engine.
Your heat pump uses helium based on your website. As far as I know, helium is extracted from natural gas, which is, again, not clean, not sustainable. So what's your argument to that?
I actually didn't know that helium was extracted from natural gas. You're teaching me some things.
Is there any other way to extract helium? I don't know. I don't think so.
I don't know, actually. That's a good question.
How much helium do you use?
So that's the thing. We don't use much helium. It's a closed system. It's just a working fluid inside the machine.
So it's an operational thing?
Correct. It's just the working fluid, so what we use to compress the gas inside the system.
Okay.
And we don't use much. The question we had was that helium is a rare gas, and that we're consuming a lot of it, so there may not be enough. So what if we scale our system at the size of the planet? So we actually did the calculation, and the impact will be just because we use a few kilos. It will be so low.
Minimal.
It's negligible.
Can you talk about today's decarbonising technology? How do existing solutions work? And what's your unique selling point in the industrial space?
Okay. Well, there are many solutions out there. You mean to decarbonize heat, you mean, or in general?
So factories are not going to buy your engine just because it's clean, right? You also have to make it cheaper and more efficient.
Yeah.
So can you talk about other solutions that are trying to do the same and how you're going to compete with them?
Correct. So there are many heat pumps on the market. They are all limited in temperature. No heat pumps, as we know of, has been able to go above 400 Fahrenheit consistently in a cost-effective way. You always have, as you mentioned, the 3 points: is the capex, the opex, so the maintenance cost, and then the performance of the system. So we think we're hitting first class on those 3 points.
So you're the only heat pump that can produce heat above 400 degrees Fahrenheit.
Correct. Right now, the only one who can do it are research projects, or they are very expensive system and they are not deployed because of that. So competition will actually be a very different technology. It will be small modular reactor, nuclear, SMR systems. Small nuclear power plant, 5 to 10 megawatt, that can be deployed quickly next to a large chemical factory, for example, and produce heat at 1,000 Fahrenheit consistently. So their main advantage is they have their own fuel, so they don't need to source the renewable, they produce all the time. Disadvantage is that you need to source that material, if it's uranium, for example, and you have to dispose after the 20 or 30 years of operation.
So your second product is a battery that is able to store energy for long periods of time.
Yeah.
Can you talk about what is the battery made of? Is it a lithium-ion battery? Is it made of nickel, cobalt? What are the components of it, and why is it better than existing batteries?
Yeah. So when we talk about battery, we usually separate them by the duration of storage. Lithium-ion batteries, they do from 20 seconds up to 10 hours. Maybe in the future they'll do 12, 15. But right now it's mostly 6, 7 hours.
And they're the most common batteries on the market, I assume.
They are the most common battery.
In our devices.
Correct. Yeah. In your phone, in your car, they're everywhere. Now, if you want to do day-to-day, so they're great when you want to store the energy produced at, say, 11 a.m. and then dispatch it at 7 p.m. But if you want to go through the night, or if you want to go through multiple days of bad weather, you need to have another system. And there are maybe 20 different technologies. One will be compressed air energy storage. You'll have flow batteries. I mean, you have a lot of different types. You have thermal batteries, so they can use molten salt. They can use sand. Really, there are plenty of options there. They are all at the demonstrator phase at this stage. No one is really deployed commercially and selling those systems.
That would be a game changer if it actually worked, right?
It would be game changer if the whole industry was moving to renewables. So what's happening right now is, let's say your grid is 100% natural gas fired, to simplify, no nuclear. And you start installing solar panels, right? So at the beginning, it's fine. Your natural gas-fired power plant just produce a bit less, and then you use all that energy coming from the solar panels. But if you deploy more than 50, 60%, so there's a threshold at which time you'll have so much energy that your natural gas-fired power plant will not be used. And at that point, you have to decide, do I subsidize that plant, or do I install storage? you still need that plant to work when there's 2 weeks of bad weather and your renewable cannot produce. So at some point, you'll need to have seasonal storage or very long duration storage. We're not there yet on the network. Right now, we're installing small storage like lithium-ion battery, like the one from Tesla, because they make sense during the day to shift a bit the consumption. We're starting to install medium-term storage, so 30 hours plus. But seasonal storage is not something that is a need right now on the market. We know it's coming, but it's a bit of a chicken and egg. You need to start first, and then maybe the first year or two you won't have the return you want, and then you will start to catch up. So.
What are these long-term batteries made of?
So the long-term duration, we're talking 100 plus hours of storage. There are very few systems. One is a startup, an American startup called Form Energy. They have their own chemical formula. I'm not too sure what they're using. Then you have hydrogen. Hydrogen is very hard to store. So the only way to make it cheap enough to store is to store it underground. So if you have a salt cavern, so just a cavern where you used to have salt that was extracted, you can pump that hydrogen in and store it cheaply. This is geographically limited. You need the pipeline to the cavern. It's a little bit complicated. Some countries don't have salt caverns at all. And storing hydrogen overground is too expensive. It's to be stored, compressed or liquefied at very low temperature. So the one we're proposing is based on ammonia storage. So ammonia is fuel you can synthesize from hydrogen. So this hydrogen today mostly made from natural gas. So it's terrible. Don't do that. What we want to do is to produce it on site. Let's say we have a gigawatt solar farm with our battery in the middle. All the extra production that is not consumed during the day, we can use that to store our thermal battery. Once our thermal battery is full, we can use the extra electricity to produce hydrogen, and this hydrogen can be converted to ammonia. This ammonia can be stored at minus 30 C, so it's cold, but not too cold. It's very cheap to store in a metal container, very large container. And you can burn that ammonia when you need to, those couple of days per year, without renewable energy.
So you're saying the reason why we don't have long-term batteries is not the technology, it's mainly the economics, that it's still very expensive?
It's still very expensive to deploy hydrogen storage. To deploy the technology we want to work on, you need our engine to make it work.
Okay.
Mostly because burning ammonia emits a lot of NOx, those small particles that are bad for your lungs. And the fact that we have this Stirling engine that converts heat to electricity allows us to have an external burner. So it's a flame that we can control very precisely to make sure it doesn't emit those NOx particles. If you were to burn ammonia in a traditional turbine or engine, it will be done inside the engine, and controlling the flame will be extremely complicated. So no one is doing it right now, apart from the maritime industry.
So how do we bring the cost down of those batteries?
In our case, it's industrializing the engine. Everything else is already off the shelf. Ammonia storage is being done for 100 years now, mostly because it's used as fertilizers. It's 100 million tons produced per year. Thermal storage has been done in the CSP industry. So CSP stands for concentrated solar power.
Which uses molten salt to store energy, I believe.
They use molten salt to store energy, yeah. There are some projects right now to use sand, so you don't have to worry about molten salt. Molten salt, when it goes below a certain temperature, it starts to solidify, which is a bit annoying if your whole system is a brick. So sand will be a great option. It's easier. It's not the sand you have on your beach that is very rare. It will be like very coarse sand.
So what type of sand?
Just regular sand.
Sand.
Yeah, you don't need to have fine sand like.
But how do you store energy in it?
You just heat it up. You heat up the sand. There's a project from, which is, it's a US lab. Is it NREL? I don't remember. If you look for sand storage, you'll find lots of info in the US about this technology.
So what stage is your battery at? Have you started working on it, or are you first focusing on the engine? And once you have the engine, you start working on the battery?
Yes, in that order. We start with the engine, and then once the engine is industrialized and we know the performance, we'll have to scale it in size, and only then will we be able to convince EPC, those engineering firms that can build the whole system for you.
And what stage is the engine at?
Right now we're still prototyping. We have a full prototype of the engine coming in June, if everything goes well. It will be a 6 to 7 kilowatt system, so very small, with a first demonstrator planned for 100 kilowatt next year. So we're right now in discussion with a food producer to install the system at their facility in France.
Why is a food factory the most optimal for your engine?
It's the easiest market we found. So this engine, the day we realized we could use it for other things than storage, now we can reach any temperature we want. We hired some consultants to help us map out the possibilities, and they came back with 50 different technologies. It was applications. It goes from LNG, reliquefaction of natural gas, so cryogenics, to freezing food, to drying papers, melting aluminum. So there were so many different applications. And for us, the easiest thing was to say, okay, we have this ideal where we want to go with a large size system and high temperature, and then we have this tiny prototype. And how do we make both ends meet? So for us, we thought proving that we can go above 360 Fahrenheit will clearly differentiate us and show that we're serious. So that was the first thing. The second thing was, okay, what's the first application we can target right at 400? And this is where the food industry came in. They need steam around 200 Celsius.
So it was the easiest industry to penetrate.
Yes. It's not the easiest to sell to or to penetrate. It's where our first product could first be applied. So.
How was working with consultants? Did you find their work highly impactful, or did you find it difficult to work with an external party?
Consultants are expensive.
Oh, yeah.
They're very expensive. And so for us, what happened is we had a tiny budget last year at $5,000. So what can we do with $5,000? So it's in France, so you go a bit further than in the US, where it was even less a day or two. But they came back to us with a map of those applications, and they told us, yes, your application works here. But what do you do after that? You have so much more work to do. So, for example, we found out that half the consumption of a gigafactory, the one that makes the lithium-ion battery, half the energy bill comes from drying the anode and the cathode of the battery. They have those massive drying systems.
When they're recycling it?
When they're making it.
When they're making it.
Yeah, when they're making it. So we thought, great. Those gigafactory, obviously they can't use natural gas just for their image. So they are using resistive heating, which is much less efficient than a heat pump. And so we could help them reduce by 20, 30, 50% their electricity consumption. But then we found out, okay, but Tesla bought a company that can make I don't remember technical terms, I'm not an engineer, but it would be, I think the anode will be deposited in a dry way. So you don't need a dryer for that part. Yeah. You still need to dry the cathode, but no more the anode. So this is an example of a technology that changes the process and is not competing directly with us, but in this specific application, kills us. And so the consultant didn't do that work. We had to pay another consultant to start again, and this can quickly cost 100K, 200K.
That's crazy. So what type of consultant was it? Was it specific to your industry? Was it a generic consultant like McKinsey, Bain?
No, that's an energy consultant. So people who are, in our case, it was a company in France that are specialized in all type of energy projects. they will go to factories and they will help them improve their process. They are specialized in taking technologies from startup and integrating it into demonstrator. So generalist in the energy sector, but still with a good knowledge of all the different industries.
And how long were you working with them?
For a month.
And that was for 5,000?
For 5,000. But when the
That's
mission
very cheap.
is for a month, but maybe they work a couple of hours here and there.
Okay.
What they do mostly is they take their phone and they set up meeting with their contact, their portfolios companies, and then ask questions. Would you use this heat pump? What parameter is important for you?
So it's mainly about the network. They have access to people in the industry that they can ask questions.
Yeah.
To produce
that's the most complicated part. Whereas a startup, when you're trying to sell something, you're not really neutral. You don't necessarily know how to ask the questions. So it's very important to have consultants that can do this job for you.
Yeah. So for people that are listening, aspiring founders, would you recommend hiring a consultant to do this type of work? Would you have done something differently?
I would not have done it differently. Yes, I highly recommend consultants to make sure you're not developing a project just because you think it's useful. It's easier in the software world to just talk to your users. You open a beta version, you can see if it works. For us, a beta version is a demonstrator that costs €1 million. So you have to be sure that you're answering the right problem, you're targeting the right application.
Can you talk about IP? I would imagine your technology is patented in some way. How difficult is it to get a patent on technology? What steps do you need to take?
So our technology is not patented and it's on purpose.
Is it open source then?
It's not open source, just secret. We are keeping the secret for the good reason is when you patent something, when you send your application to get your patent, it takes roughly 18 months. And after that, your patent is published. And at least that's the case in France. And then it's very complicated, a patent world. You can extend your patent in different regions. And it's quite cheap, cost 5,000 to 7,000 euros, so maybe $8,000 per patent in France. So that was very cheap. That's easy. You just go to a patent office, you explain them the tech, they write it for you.
They do the write-up for you?
They do the write-up for you, if they're good. Of course, they ask you lots of technical info, but they do the write-up. It looks like a lawyer wrote a document. So it's, I don't know if you ever read patents, but it's specific language to patent lawyers. And for us, it was really making sure that when our patent is published, we have the strength to stay ahead of the competition. Let's say you need 5 years to go to market and you put your patent on the first year. After 18 months, it's published. All your competitors are much bigger than you, start to work or look at your technology, maybe improve on it, bypass your patents. So it's a timing question for us.
Have you thought about licensing it?
Yes. There are many applications that I mentioned, for example, liquefaction of natural gas. It's not something we can sell by ourselves. Like in France, there's only one company that does that. So if you don't work with them, you have no chance. And it is not something we're interested in doing. So we'll work on the engine, do the design, and then adapt it and license it.
Obviously, like developing this breakthrough technology is a very long process. You started in 2016 and requires lots of R&D. And in most cases, these very capital-intensive projects lead to failure.
Yeah.
If you look at the pharma industry, what gives you confidence that this won't be a failure?
That's a good question. We nearly failed.
You nearly failed. Tell me about it.
3 or 4 times.
Tell me about it. I love hearing about failures.
So when we started 2016, I met my co-founder. He was out of his PhD. Had no money, really nothing. I had another company that I started before that was still giving me some funding. It was not, even though I was not actively working on it. So I was not paid for the first 4 years of the company. And in France, when you have an idea and it looks a bit crazy and you're telling people the first demonstrator will be a megawatt size and you have never worked in the industry before, no one will give you money. So it was really hard. We managed to get a few grants, 10K, 20K, 40K, enough to build a tiny prototype and incorporate the company. And then we had to move to the US. That's why we applied to Y Combinator, got accepted, very lucky, and raised 500,000 just based on the idea in a few weeks after the demo day. So
how many people were you at the time?
we were 3.
All co-founders?
No. Me, Andre, my co-founder, and our first employee.
Mm-hmm. How was the Y Combinator process? So for people who don't know, Y Combinator is the best startup accelerator in the world, and it's very competitive, very hard to get in.
I think at the time 7,000 startups applied, and they took 120.
Crazy.
Most of them are in the software world, but they take some moonshots here and there.
Yeah.
So there are people doing supersonic planes or fusion reactors.
So why YC if it's mostly software focused? Why not another accelerator that's more focused on hardware?
That's the one we thought about. They were looking specifically for companies doing energy storage at the time. So we thought, oh, right, that's in scope. They also have 20% of their startup doing hardware.
Yeah.
It was a bit harder when you do hardware to raise funds because their investors profile, the one that comes to the event, are mostly interested in software. But still, there was some very good names that we met there. Sorry, that invested in us and put their trust in us. Yeah.
What was the main value that YC added to your startup?
So many things. It's really hard. Like the network is just incredible. I remember that we tried to build a prototype during the summer at YC. We bought some metal, and we found out that this metal cannot be exported back to France. You need ITAR documents. I think it was molybdenum, something that they used to make a missile.
Yeah.
So we needed some kind of authorization from Department of Commerce or something. And we were in a house that we rented in California. We had this piece of metal that cost a fortune. And so we just sent a message to the network, say, hey, what do? We tried to call some trucking company. They're asking us for a little fortune to ship it back to France. We don't know how to do paperwork. And then in a couple of hours, someone said, hey, I have a warehouse. If you can drop your plate there, we can pack it on a pallet for you. Another guy said, hey, I have this contract with FedEx. I can overnight it for you for $500, which was a third of what they were quoting me to do a maritime shipping that took 3 months. And someone else came in and said, I have this crazy consultant. He can do all the paperwork for you for $200.
So it was mostly the network, you think?
Incredible network.
Incredible network.
We still have a group of YC founders in Austin. We're actually meeting very soon. In France, same thing. Hundreds of founders in a WhatsApp group. So.
Is there anything you would have done differently during YC? Do you recommend that people that are about to do the summer batch focus more on building product? Or focus more on networking, or focus more on speaking with partners?
I think our main mistake is to, how can I say that? We had an engineering mindset. We thought, okay, this technology doesn't exist. Let's raise some money. Let's build a prototype, and then let's show it. Prototype ended up taking 3 years. After 3 years, we had some university professor that did a study for us on corrosion, and he found out that it was not going to work. So we nearly died after in 2019. So we had to reboot the tech. The way we should have done it would have been different. We should have started saying, okay, we have this idea. We don't know how to do it. We've never done an industrial product. We're not going to build a prototype like right now. We're going to build a board of advisors. We're going to come with them to YC and raise fund based on that. Like we went alone, if you want. And after 2 years, if you don't have something, 2, 3 years, if you don't have something to show, people start to lose faith. The wave of investors, they invest by wave. Like there's the hydrogen wave, there's the heat pump wave. If you miss the wave, you're too late. They pick a few horses, that will be the winner. They dump $100 million on them, and it's really hard to catch up. And so we had to, if I had to do it differently, yes, I would have raised $2 million just to get like the board and maybe a basic concept and the market, maybe the first customers, first LOI, and then raise the bigger round and build the prototype from there.
So are you saying board is mainly for credibility?
Board is for credibility and also to give us the advice. We didn't have that board. We didn't know, for example, at the time we thought, I remember when we started, my co-founder was like, yeah, in a year I can get a 1 megawatt prototype. And now we know 1 megawatt takes at least 5 years to get to market.
Yeah.
We were very naive. My co-founder was out of his PhD. He didn't know what it takes to build such a machine. That's part of why it works as well.
I think you still don't know what it takes because you haven't got there yet.
True, and I think that's why we're crazy enough to try those ideas. It's because we basically don't know what's behind it. If we knew, we would have been discouraged and never tried. And when we nearly died in 2019, my co-founder disappeared for 3 months, and he came back. He said, "Okay."
And that was just based on the professor's recommendation.
Yeah,
How did you meet this professor? How did you deal with his findings or suggestions? And what did you do after that?
It was really hard. We had a PhD working with a specialist in material science and corrosion, and she started a study with this professor that took, I don't remember, a year and a half or 2. And when the study came back, he was, okay, everything's fine, and suddenly, after months, it breaks. And it's going to take you 5 years to find out how to bypass this issue. So we knew we had a massive problem. And this is what's happening right now in France with the nuclear reactor. They've been in place for 20 years, and they're only finding now corrosion issues that no one expected to happen. Corrosion is really hard. So we were about to close the company. It was a really tough time. We were running out of money. We had those 500K from YC. From 2019, it was a bit the end. And so Andre left for 3 months, came back, said, okay, I reinvented something. I think it can work. It's a bit crazy. It uses some components that we developed during those 2 years. It doesn't have a corrosion issue anymore. We completely removed the liquid metal that were in the system that were creating corrosion issues. And we restarted from scratch. And the first prototype came in around end of 2020, 21. So it was just a piece of the engine to show how we can compress the gas. Now we're building the whole engine.
So what's your role in the startup since you're non-technical? Your co-founder is the engineer, the PhD. Yeah. What do you do day to day?
I'm a fixer. That's how I like to call myself. COO is the official title, but everything that requires to organize something. So I will go, my co-founder will tell me, hey, I don't know about this topic, can you find me an expert? I'll go search on LinkedIn for the right person. People send us an email, I will set up the meetings, I'll make sure we do the follow-up, I'll do the accounting, I'll do the fundraise, recruitment, so many things, finding a new warehouse. That's insurance, there's so many topics. You have to, it's not a job I like to do. I'm a salesperson by heart. I cannot wait until I can move on. So, which I started to do since last year. We hired an office manager. She's amazing. She does everything I used to do. So, and now I can focus on more on the market research and understand how to sell that system.
So you developed your prototype in 2020, you said?
We started the first iteration, like we were 3D printing, it was all plastic and with water, low temperature, and now we're building a machine that can go to 400.
And based on the first prototype, you raised your seed round in 2021?
In 2020, we wanted to do a fundraise. COVID happened. So again, we nearly died. We got a loan from the French government that saved us, 350K. a COVID loan, gave us a year of runway, a bit more. And we started a crowdfunding in, when was it? April 2021. Friends from YC told us, why haven't you tried this? They were doing propulsion systems for satellite. They raised $1 million in 6 months in crowdfunding. So we took 300K from people in our network, angels, and then we opened on the platform, raised $1 million in a month. It was incredible.
Awesome.
And that was our first fundraise after YC in crowdfunding. So we closed the crowdfunding because we reached the limits set by the SEC at the time. And those limits changed.
What's the limit?
It was $1.08 million from non-accredited investor. We could not raise more than that. And crowdfunding is mostly non-accredited investor. So the 1.27 we raised, the difference was from people who gave us 100K and they were obviously accredited. And we reopened the crowdfunding this year in October. So far, we have 620K committed, much less than 21, but the economic conditions are very different now. So.
Yeah. Have you tried raising from VCs? Have you had any conversations?
We tried, of course. We had a lot of conversation. It's a very interesting topic. What happened in the clean tech world is there was a big wave of investment in 2009, 10, 11. A lot of those bets didn't work out. And there was some kind of cold wave, if you want, where no one was interested in clean tech. And it came back around 2018, 19, and now it's, of course, full speed. And when we went to see clean tech VCs, most of them were afraid of hardware because the time to market for a hardware company, 7 to 10 years, it's longer than the time of their fund. There's a lot of scientific risk, which they hate because they cannot really model what the dilution will be. A lot of investors will ask you, how much will you need to raise to go to market? I don't know, maybe it's 10, maybe it's $100 million. It really depends on how the market evolves. And so it's really impossible to predict that. And the math wouldn't work out for a lot of them. So if you looked at the portfolios of clean tech VCs, 90% will do software. You know, how to improve the efficiency of the AC system in a building or do carbon accounting. Only a handful are doing pure hardware bets, like breakthrough energy venture, lower carbon capitals. Mm-hmm. So those are the firms we can contact for our Series A.
Mm-hmm. So when will the product be out in the market? When are you expecting that? 2025,
first machine, if all goes well with the demonstrator.
And that's going to be in France, in food factories?
I'm not sure if it will be in food factories, but it will mostly be in Europe. France, not sure, but Europe for sure.
Mm-hmm. How do you think about investor payoff? Like, what are your investors expecting from you? What are their questions to you when you have conversations with them? Are they technical? Do they understand the engine and how it works? Or do they mostly have faith in the team and they trust the team?
They mostly have faith in the team. We only have one VC that gave us 200K that understand deeply the technology. They're physicists from CERN and they really know what they're doing. But most people, they root for us because they know it's a cause that we need to work on. And at the stage we're at, we cannot disclose the inner working of our system. So it's really based on credentials, what they think the product can be worth.
You don't disclose how the engine works at this stage?
Correct.
To investors?
Correct.
Seriously?
Yeah.
So they
don't need to understand it. Because if I tell you the compression mechanism, it's basically equations. It's pages of equations, it's numerical simulations. Very few people can understand how that works.
Well, I would imagine that they would take whatever you give them and give it to someone who will understand it, right? Or how do they do due diligence then?
So Series A investor will need to understand it. So if you raise, let's say, $5 million Series A or more, of course, the lead investor that is putting $2 million will want to understand what's going on. He wants to assess the technical risk, the scientific risk, There's a big difference between the two. He wants to...
What's the difference?
So scientific risk is, okay, is this magic or is this actually physically possible? Once you know, like fusion, right? Is the theory working? Once you have that, is technical risk. How hard is it to scale the system from the prototype to a full machine? And it could be, I don't know, the machine to CNC the part, to cut the part for prototype is small, but when you want to scale it, the part suddenly costs a lot more, or the part breaks. So this technical risk is usually well understood and acceptable. Yeah. Scientific risk is where it hurts. So the VC will want to see the patents. They want to make sure it's protected. They want to understand the technology, the risk profile. They want to understand the markets. They want a full technical, economical study.
But you said you don't have patents now.
We don't have patents. We will have them before the Series A.
Okay.
So our goal is to raise funds soon, because obviously we'll run out otherwise, so probably this year. I cannot disclose too much about our plans due to the SEC regulations with crowdfunding. But if you go on our page, we're talking about this. But yeah, of course, we'll have the prototype, we'll have the patents, we'll have letters of intent from customers, first customers for the demonstrator.
What challenges are you experiencing currently? What's the major roadblock in your journey? Cash.
If I had cash, I will triple the amount of engineers get this machine out now. We're really, really struggling with manpower.
How many people do you have now? And what are their roles?
I think we're 16 now, including the
16?
intern. 16, yeah.
Is it engineers mostly?
We are only 2 non-engineers, non-PhD in the team. So me and my assistant. Everyone else is engineer from the top schools in France. So
are they all full-time?
They're all full-time, except 2 of them who are interns. We have a mechanical engineering team for engineers. We have a data scientist. She specialized, she did a PhD in energy modeling for the grid. We have a specialist in combustion. He works on the ammonia burner in Belgium, inside the lab. We have 2 physicists, my co-founder and our CTO. And we have a numerical simulation team with 2 engineers and 1 developer. Yeah.
How do you go about hiring? How do you decide, okay, now we need to hire a full-time person versus hiring an intern or outsourcing it to someone else? How do you know when to hire someone and what position?
The choice is very quick in France. If you hire someone and is doing R&D, you get tax credit up to 40 or 45% of his salary. If it's a young PhD and if his first job after his PhD, 100% salary paid for 2 years. And for us, because we do deep tech, we needed the PhDs. So the first hire we did were only PhDs. That's why we lasted so long with 500K. Nowadays, the mechanical team, they are not PhDs because they don't need to. PhDs are more on the research side. They will not be doing like the CNC, the machining, the soldering, the conception.
Don't you think you need someone with industry experience?
I would love to. We don't have the money. It's always the same problem. We cannot pay 100K for an experienced engineer. So we are relying on our advisors. We have an amazing advisor. He's a specialist in aeronautics. And he built a storage system very similar to what we're doing, but 10 years ago. So he's the one validating our design and telling us what will work or not.
Mm-hmm. How are you planning to price the product once it's in the market in 2025?
It's a very good question. First, before we price it, is how do we sell it? You have a lot of different options. You can sell the machine, you can lease the machine, you can sell the heat as well. So let's say if you're an industrial user and for the last 40 years you've used natural gas, and suddenly I'm telling you switch to electric, you have to supply that electricity from somewhere. Buying it from the market where the price changes every day, it's quite complex. It's a different job. Big corporations with multiple factories have a whole team who can do that because they use electricity also. A small factory, they won't be able to do it. So for them, it makes more sense to sell them the heat. You say, okay, I handle the machine. I have a specific company that supply me electricity, and then I sell you the heat. So that's where our thinking goes into right now. It's who will be the first ideal customer? Do we want to handle the electricity pricing or not? And then based on that is, okay, of course, if we sell heat, we have to compare it to natural gas. What's the price of natural gas versus what we can deliver? We priced it based on that.
Mm-hmm. Yeah. Your two co-founders, can you talk about any conflict you've had, or how do you resolve arguments?
I only have one co-founder, Andre, and we never had arguments. Yeah, it's amazing.
You agree on everything?
Yes, mostly.
Wow. How do you go about working? Sorry.
Yeah, we disagree on things, but we never fight about it.
How do you disagree?
How do we disagree? I have a viewpoint, he has his viewpoint, we talk about it, and we decide on the best way based on logical arguments. That's usually how it goes. So far, so good. Yeah, we made mistakes, we disagreed, but nothing that can prevent us from moving forward.
Mm-hmm. So you're always able to find some kind of compromise between your two viewpoints. You're the only person based out of Austin. Everyone else is in France. Can you talk about remote work? How do you communicate with your team since you're in a different time zone? How do you go about hiring remotely, working remotely with your team, motivating them?
That's a very complicated thing to do. I only have a couple of hours to work with them. There's a 7 hours time difference. The fact that I'm not an engineer is helpful. I can talk to them at the end of their day, and because I mostly do operations, it's telling them about the strategy of the company, where we're going, what are the timelines, and I spend a lot of time talking to customers, either in France or in the US. I usually have an hour with the team to talk to them individually. So every day I try to talk to a different group and make sure we're all aligned. But it's fairly easy. I wish, of course, I was in the office. It would be so much easier. But it is what it is. We have all our investors here, a lot of potential customers here. So it makes sense to.
What tools are you using for communication? Is it Zoom? Is it Slack? Is it Discord?
We use Signal.
Signal.
So
you have a group chat, and that's how you communicate.
Group chat, yeah. Signal and secure messaging, and that's it. Yeah.
Mm-hmm. Do you have any hiring tips? Like what questions are important when you're hiring first employees? What do you need to figure out?
As a non-engineer, I cannot really tell if someone is good or not. So usually we take them for a couple of months, and if it doesn't fit, then we let them go. It never happened to us. When we hire people, they usually are profiles that came to us. We rarely put advertisement for jobs.
How do they find you?
There are listings of startups in the climate tech or from YC. Usually, from our network, we're based close to Polytechnique, which is like MIT in France. So all the top schools in France are in the vicinity. We go to events every year. People know us. There are not that many hardware startups in the climate tech space.
So you have a good inflow of PhDs coming to you.
Oh yes, it's not hiring for us is not a problem. Hiring experienced people is hard. In France, most companies are, let's say, large SMEs or large corporates, and they do not have that ecosystem of startups with people that spent 30 years in different startups and they still have that industrial experience. When we try to hire someone that worked 40 years for a large French company, the culture is so different that it can be really hard sometimes to understand each other.
Yeah, that's a good point. Culture clash.
In America, there are so many startups with a lot of talents, people that work, 40 years of experience and all their life doing crazy projects for startups.
A friend of mine recently told me about a new book that came out, which is called Fossil Future: Why Global Human Flourishing Requires More Oil, Coal, and Natural Gas, Not Less, by Alex Epstein. And he argues in that book for increased use of fossil fuels because of low cost, reliability, and because it's the easiest way for the poorest areas to get energy, right? So what is your counter-argument to his arguments of low cost, reliability? Fossil fuels is the reason why we have been able to progress so far and why so many people in the poorest areas have access to energy. And renewables are actually doing the opposite. They're causing skyrocketing electricity prices and increased blackouts, right? So what are your counter-arguments to this?
The increasing blackouts, for sure, this is not true. Increasing blackouts, if it's talking about the one we had in Texas 2 years ago, this was not due to renewables, just due to poor planning and maintenance. They don't have blackouts in Quebec or Canada when it's freezing. So I don't think this is true. Now, of course, fossil fuel helped us in the last 200 years build this society that we had. But the way I see it is we had a big party, lots of booze, everyone got drunk, and now we need to clean the house. And if we don't do it now, it will be too late for the planet in general. Of course, there are a lot of people in poorer countries that need access to cheap energy. But we have the money, we have the funds to help countries to get access to renewable energy. There are plenty of resources out there, so I don't think it's a problem. Cheap energy is necessary to keep our lifestyle, but do we need to keep the same lifestyle? Can we afford to keep the same lifestyle? I truly believe we will have sacrifices to do. It will be hard, there will be tears, and it will be complicated for a lot of people if we want to avoid mass extinctions of species, if we want to avoid wars, if we want to avoid mass migrations of people where their land became inhabitable.
So are you saying that poor people should make a sacrifice and lead lower quality life so that we can have a better planet?
We should make a sacrifice.
We should make a sacrifice.
I come from Europe, and when I arrive in America, it's really striking, the difference in the size of cars. People leave their TV on or their window open, even if they have the AC. Everyone has AC. It's funny, even here in Texas, we had cold weather a week ago or 2 weeks ago. My apartment had AC on. The building has AC on when it's 1 degree outside. Yeah. That's crazy. It's people do not realize the cost of the energy because it was so cheap. So again, this comes back to what I said. We're in a house and the booze is free and everyone is binging and drinking too much. But the day they realize what it actually does to your body, does to the environment, we're going to have a strong wake-up call.
I agree. So lastly, I want to talk about your advice to aspiring founders. What would you recommend them? The ones that got accepted to YC and are going to start this summer, the ones that didn't get accepted but still want to pursue their ideas. What is your advice to early stage startup founders?
In the hardware world or in the software?
Whatever you want.
Generally?
Yeah.
I would say that being accepted or refuse YC is not the end. Of course, when you're accepted at YC, it helps a lot to fundraise. It kind of validates your idea. But even then, I've seen so many startups at YC fail, even during the batch. And I've seen people accepted to YC with idea I will not have given them a cent. And why did they get accepted? Not because their idea was great, but because the partners at YC understood that those people had the potential to reinvent themselves, that they were asking the right questions. They were, they had the energy in them to go. Driven. They had the energy to do what it takes to succeed. And I had so many examples of that, of people where their company after a month in YC failed and they rebooted and managed to raise millions of dollars and get 100,000 users after 3 or 4 weeks. So it's really to have this drive in you, which is what my co-founder Andre had. Started with nothing for a year, ate pasta, and still managed to survive because he had this will to make it work.
That's amazing. We need more people like that. We need more people that take risks and are willing to spend their 20s, in a lab or working on a startup and fail. How can people find Airthium and how can they follow your progress?
On our website, airthium.com, so it's AIRTHIUM. We have a WeFunder page. You can also find it on the website. And if you want to invest, of course, you're welcome. If you want to know more, you can also talk to us, send us an email. It's contact@airthium.com.
Awesome. Well, thank you so much, Franck. And it was a pleasure speaking with you.
Thank you so much.